This video is going to look at how we can calculate the arc length and also the area of a sector. Now, before I get into those topics, I want to go back and recall. Remember when we talked about defining a radian? We said that theta was equal to S over R, okay, where S is the arc length, R is the radius, and then theta would be equal to our angle in radians. So the S, which is, again, this is arc length divided by the radius. So if we have this formula and we want to find the arc length, well, if theta is equal to S over R, then we can simply solve for S by multiplying both sides by R. And if we do that, R is going to cancel out, and we're left with S is equal to R times theta. And that's exactly what we want to use for calculating or finding the arc length. So therefore, we're going to use S equals R theta. Now, there's one thing that we have to be very careful here. The angle, if you could realize over here, in this definition here of what was theta, theta was the angle in radians. So when we use this formula, theta must be in radians. Okay, so what that means is we cannot plug in degrees. So if your angle is, for example, 45 degrees, we can't plug 45 in for the angle. We would have to use the radians, which would be pi over 4. Okay, so keep that in mind anytime you're using this formula S equals R theta. So let's look at an example here. If I was to give you the radius of a circle to be equal to, let's say, 9 feet, and they tell us that the angle is equal to 60 degrees. So we're going to use our formula here. We want to find the arc length, so we know S is equal to R times theta, the radius times the angle. So therefore, we're going to use S equals the radius of 9, and then we're going to multiply by the angle theta. So we're going to multiply by 60 degrees. Is that correct? Well, remember, what did I say up here? This angle has to be in radians, so we cannot use the degrees. So be very careful. So what that means is we have to change the degrees to radians. So if we want to change this to radians, remember, what do we have to multiply by? Well, if we want to go to this, we have to multiply by pi over 180 degrees. And if we do that, we would have 60 pi over 180. And if you reduce that fraction, that's going to be equal to 60 into 180 is 3, so you would have pi over 3. So over here, we have to use pi over 3 as our angle. So that's what I mean up here when I say this angle has to be in radians. So now we can multiply this out, and we would get 9 pi over 3. And of course, then we could simplify that. So we would certainly just end up with 3 pi. Now remember, S here is representing the arc length. Now, remember, if we think of that here in terms of our circle, if we have, let's see here, the angle is 60 degrees, or pi over 3, so we know 60 degrees, or pi over 3, is going to be approximately right about here. So this was our 60 degrees, or the angle pi over 3. And really what we're looking here for, when we say we're looking for the arc length, we're looking for the length of this curve right here. So what that means, if you were to take a string and you were to measure this blue line here, this part of the curve, this here is going to be 3 pi what? Now be careful, this isn't the angle. The angle is the pi over 3. But here, 3 times pi is representing the length of this part of the circle. So here, this is going to be equal to 3 pi. Now, what was our units? We do have units here. Well, if the radius was 9 feet, then that means here this would actually be equal to 3 pi feet. Now, that probably isn't something pretty standard you're going to see. Normally here, if you're looking for this length here, this would be classified as what we would call an exact answer, because we leave it here in terms of pi. And really for this problem, I would say we would want to actually multiply 3 times pi. So if you go to the calculator and we multiply 3 times pi, you're going to get approximately let's say 9.42. So approximately 9.42 feet. And this here would probably make a little bit more sense to us because we can kind of visualize what does so this is almost 9.5 feet. So this is approximately 9.42 feet. And this would be what we call an approximate answer. So if anytime the book or the question says give the exact answer, then most likely that means an exact answer. We're going to leave it here in terms of pi. And if they want approximation, then we're going to actually multiply this out into a decimal format. So what that means is if we have here a circle that has a radius of 9 feet, so this is 9 feet, and what we're saying then here, if this is the angle of pi over 3 or 60 degrees, the length of this arc here is going to be approximately 9.42 feet. So that's how we can calculate the arc length. And really, if you're looking for anything here, we have the formula we set up here is theta is equal to S over R. And really, as long as you know 2 of these, you can solve for the missing piece. So if we really wanted to find the radius, if we were given the arc length and the angle, we could certainly solve for the radius as well. Okay, just keep in mind that anytime that you use this formula, or this one over here that we have for arc length, this angle theta has to be in radians. Okay, so now let's look at finding the area of a sector. So what does that mean? Well, if we're looking for the area of a sector, then basically what that's talking about is if we have our circle here, and maybe we have this angle right here, and we want to know what is the area of this piece right in here. So if this is our radius here, and then of course, if we have the arc length and then this other part, so we want to know how much area is within this particular region. So in order to find that, the formula is going to be area is equal to 1/2 the radius squared multiplied by the angle. And that's the angle right in here. This is that what they call central angle here. This is the angle formed in the circle. And once again, this angle has to be in radians. So if you're given the angle in degrees, you have to change it to radians. So we'll look at one example. This is fairly straightforward. Just plug in to find the area. All you need to know is the radius and the angle. So if you're given the radius of the circle is, let's say, 12, we'll say millimeters, and the angle that is formed is pi over 4. Now we're in luck here because the angle is already in radians, so we do not have to worry about changing the angle here to radians. So if we plug into the formula, we have area is equal to the 1/2, the radius squared, so that would be 12 squared, and now we have to multiply by the angle pi over 4. And now we're going to multiply this out, so we would have 1/2 times 12 squared. So we could kind of look at it this way. We have 1/2 times 12 squared, and that's going to be 144 times pi over 4. And I want to kind of leave the pi alone, but we have 1/2 in the 4, so that's the 1/4, so we could really think of that as being 1/8. 2 times 4 is 8, so we get 1/8 times 144. times the pi. And I'm just doing this by hand. You could certainly put this straight into the calculator. And now we want to multiply this. Now notice when I put this into the calculator, whether you go 1/2 12 squared times 1/4, or whether you type in the calculator 1/2 144 times 1/4, notice we do not want to enter in the pi. We want to leave the pi as a multiple of pi. So all we're going to do is multiply out the numbers. So we can actually do it on the calculator. And just for practice, I'm going to type in the whole problem from the beginning where we had 1/2 up here times 12 squared. So 1/2 multiplied by 12 squared. Okay, and now instead of the pi over 4, I'm going to ignore the pi and just multiply by the 1/4. So we want to multiply this by 1 divided by 4, and we get an answer of 18. So now I know the answer is going to be 18 multiplied by pi. Now, what is the units? Well, we started up here with the radius as 12 millimeters. So the 12 millimeters would really be in here. And notice here we're talking about area. And anytime you talk about area, it has to have a square unit. Well, that's because when we square the 12, we're really also squaring the millimeters. So therefore, the unit is going to be millimeters squared. And this answer here is considered to be the exact answer because we did not round. We left it in terms of pi. Now, once again, you may do that for some examples, but I think in reality, you're going to actually multiply that out because, again, as far as area, it's probably hard to understand what is 18 pi square millimeters. So I would suggest in this case to actually multiply this out. So we could go to the calculator, 18 times pi, and we come up with 56 we'll say 55. So approximately 56.55 millimeters squared. And this here would be the approximate answer. Okay? And it's going to tell you in the directions whether they want the exact or the approximate, or if they want you to give it as a decimal or as a multiple of pi. So don't worry about which answer they're looking for. They will tell you. Okay? So in this video, you've learned how to find the arc length using S equals R theta. Remember, theta has to be in terms of radians, and how we can find the area of a sector. And once again, if we use 1/2 R squared theta, the angle theta has to be in radians. So if you're given degrees, you must change that into radians before you substitute into the formula.